So in this video, we're going to look at solving inequalities, and we're going to see that the strategy for solving inequalities is similar to that of solving equals, things that have equals in them. So the solving strategy for solving problems that have inequality in them, so greater than, I guess that's the less than symbol, less than or equal to. Are all of my examples less than? Oh goodness. We'll have to make sure that we do some that have the symbol going the other way in class. So distribute, optional to clear the fractions, optional to clear the decimals. You can combine like terms on the left side and on the right side. Use addition with your goal to get the variable term on one side of whatever symbol you have. So this symbol could be right here, the greater than, the less than symbol, the less than or equal to symbol, the greater than symbol, or the greater than or equal to symbol. It wouldn't matter which one of those symbols it is. And then you use multiplication and division with your goal to isolate the variable. And I just make the note that when you multiply or divide by a negative number, you must flip the inequality symbol. And we'll be looking at why that is in class. And so that'll be something that we'll be looking at. And then you need to graph your solution on a number line. And so we'll practice doing that. So here, when I want to solve this, there is no distributive property. There are no like terms on this side. There are no like terms on that side. So all I have to do, use addition and subtraction. So I'm going to take away 5 to get the variable on one side and the number on the other. And when you take away, you leave the same symbol. So whatever symbol you have, you leave it there. And this is going to give us 2, and this is going to give us x. So x is smaller than 2. And then they want us, so that's our answer. And then they want us to put it on a number line. So we're going to also graph our solution on a number line. So here's where 0 is, here's where 1 is, here's where 2 is. And our solution for x does not include 2. And so our values, our solutions for x are all smaller than 2. And the things that are smaller than 2 are this direction. But it doesn't include 2, so you would put an open circle at 2 to show that it doesn't include 2. So there's our graph. This is example 4. Negative 3a is less than or equal to 18. And I don't have any distributive property or any like terms to combine. And the variable term is on one side and the number is on the other. So I only have the last step, which is divide. And when I put my finger, what I'm going to be dividing by is negative 3. And when you divide or multiply by a negative, remember it was negative 3, when you multiply or divide by a negative, if you have the less than symbol, less than or equal to symbol, you have to turn it into the greater than or equal to symbol. So we're going to divide here by negative 3 and divide here by negative 3, and you have to flip this symbol. And we're going to be looking at with some numbers why you have to flip the symbol in class. And so it'll be part of our lab. So a is greater than or equal to, and then 18 divided by negative 3 is negative 6. And then we're done. All we have to do is graph this on a number line. And so here's where 0 is, and here's where negative 6 is. And this time that our solutions for a do include negative 6. They're equal to negative 6. So I'm going to put a solid circle to show that it includes negative 6. So open when it doesn't include, and closed when it does include. And then our values for A are greater than -6. So our solutions are greater than -6, bigger than -6, which is this direction. So there's our answer there. So a lot of times people say that if I have the less than symbol or the greater than symbol, then you're going to use an open circle. And they're certainly right. And the less than or equal to symbol and the greater than or equal to symbol, you're going to use a closed circle. And that's certainly a true statement. And then example 8 here. This one does have distributive property that I need to do. So 2 times 1 is 2. And 2 times -3 is -6x plus 4 is less than 4x minus 14. And then the second step would be to combine like terms. And these are like terms. 2 and 4 are like terms. And it doesn't matter which one I write first. If I write -6x plus 6, 2 plus 4 is 6. Or if I wrote 6 minus 6x, doesn't matter. And so less than 4x minus 14. So when you use the distributive property, you don't change the symbol. When you combine like terms, you don't change the symbol. You leave the symbol exactly the same. So if it's the less than symbol, you keep it the less than symbol. And when you add or subtract to get the variable on one side and the numbers on the other, you leave the symbol the same. And it's your choice which side that you put the variable on and which side you put the numbers on. I usually put when it's inequality, I usually put the variable on the left, but you could do it any way that you want. And so you could say that over here is where I would want to put the variables, and over here is where I'd want to put the numbers. So VAR for variables and NUM for numbers. And so -6x is on the correct side of this equation. It's a variable, but I'm going to take away 6 from both sides. And I'm not going to line it up with the 4x because those are not like terms. I'm going to line it up with the 14. And so now this would be gone, leaving only a variable on that side, which is what I was hoping. But on this side, I have a variable, I have a number, and I have a number, which I was just hoping to have numbers. So I want to get rid of the variable, so I'm going to undo it by taking away 4x. So when the dust clears, when you add and subtract, you don't flip the symbol. You leave the symbol the same. So when the dust clears here, I get -10x is less than -20. And then I'm going to put my finger on x, and I'm going to be dividing by a negative. And remember, when you divide by a negative, you have to flip the symbol. So I'm going to divide by a negative here, and I'm going to make a note to myself, flip it. Flip it good is what I'll say here. And so I'm going to get here x. I'm going to get the symbol flipped, and I get 2. So x is greater than 2. And on a number line, that looks like here's 0, and here's 2, and greater than, it doesn't include 2, and greater than is this direction. Now, you would get the same answer had you put the variable on the other side and the numbers on the other, and sometimes people misgraph it when they do that, but certainly it would give you a similar answer, the same equivalent answer, not similar answer, an equivalent answer. So you're certainly welcome to do that. Okay, so that is section 1.8, and as always, there's more examples in the book if you're looking for more examples. Okay, and so we'll talk to you later.